So now let's move on to regression model evaluation. And the three evaluations we're going to go to is the score method, or the R2 squared, also called the coefficient of determination, the mean absolute error, and the mean squared error. So first I'm going to do the score method, and the R2 score, or R squared, measures how well a model predicts outcomes by showing the percentage of variation in the data it explains. So a score of 1 or 100% means the model perfectly predicts the values, while a score of 0 means it does not explain any variation, which is poor results. So first I'm going to create a baseline random forest regressor model, and then I'm going to print the score. So first I have to import the libraries that we're going to use. Let me run that cell. Actually, I have to also import train test split. And we have a mistake. Let's see. I misspelled numpy. Let me import train test split. So now let me create the baseline random forest regressor model. I've done this in a couple times in previous lessons, so I'm just gonna speed through this. So the model.score function, it brings our R2. Another way to bring the R squared or R2, or also the coefficient of determination, we could import R2 score from sklearn metrics. So from sklearn.metrics, import R2 score. And first we have to get the predictions of the test values. So y predictions equals model.predict, and here we put the x test. Then we're gonna set a variable called R2 and call the R2 score function, and the first argument is our y test, and then the second is the y predictions. And now let's look at the R2. Scroll down, and you see it brings up the same thing. So the .score function brings up the R2. And the R2 score, or R squared, measures how well a model predicts outcomes by showing the percentage of variation in the data it explains. So now let's move on to mean absolute error. And the mean absolute error is the average of the absolute difference between predictions and actual values. It gives you an idea of how wrong your model predictions are. So let's import mean absolute error. So the mean absolute error and the arguments it takes is the same here. The y test and the y preds. We already put our y predictions in the variable y preds here. So now let's look at our mean absolute error. Let's run that. And we get a mean absolute error of 0.32. So the way how mean absolute error works is it takes each prediction and subtracts the actual value from it. If we get a negative number from a prediction, when we do the subtractions, it will be changed to positive. This is why it's the absolute value. And then we average all those differences. So any negative value that we get from subtracting the predictions from the actual value, we turned it into positive, and then we find the mean of those values. So now let's move on to mean squared error. And the mean squared error is another way of measuring how far off your predictions are from the actual values, but instead of just looking at the differences, it squares them first, then calculates the mean. And this helps make bigger mistakes stand out more. So now let's import mean squared error. So from sklearn.metrics, I want to import mean squared error. Let's create a variable called MSC and set that equals to the mean squared error. And then we're putting the same thing because we already put our predictions into the variable ypreds. Control C and Control V to paste. And now let's look at the mean squared error. And we see our mean squared error is 0.25. So now let's move on to the cross-validated score evaluation. So this performs n-fold cross-validation on your CLF model using the features X and the target Y. If we don't specify a scoring method, the cross-validation score uses the default, which is the R2 score. So let's import cross-validated score. So from sklearn.model, import cross-val score. And let's set the random seed for reproducibility. So I'm going to set a variable CVR2 and set that equals to cross val score. And then the arguments it takes is our model, which we stored or initiated our random forest regressor in, the X, the Y, and we just want a cross validation of 3. Usually we would do 5, but let's just do 3. And we set the scoring to equals none. So like we said above here, if we set the scoring to none, by default it will bring the R2 score. So now let's look at our cross-validated R2 score. And we made a mistake. Let's see here. I misspelled sklearn up here. Let's run that. Okay, it's supposed to be sklearn.model selection. Let's run that. And here you see we splitted our data into 3 subsets, and we get a score for each of these 3 subsets. So to get the R2 score, we find the mean of these values. So use numpy, the mean function, and we put in our variable that has our cross-validated values. Let's run that. And the average of these scores is 0.65. So now let's move on to the mean absolute, cross-validated mean absolute error. So I'm going to create a variable called CV mean absolute error. Then I'm going to cross-validated score. I'm going to put our regressor model, X, Y, CV equals, let's put 5 instead of 3. It might take longer on your computer, but not that long. And here I'm going to put negative mean absolute error. And to find the mean absolute error, we have to put negative in front of it. So let me explain why. So sklearn converts the mean absolute error into a negative value to fit its scoring framework, where it prefers higher scores for better performance. So by making the mean absolute error negative, it allows sklearn to rank models properly. So a less negative score, or if the score is closest to 0, it indicates a better performance or smaller errors. So let me just write a note up here. Let me move this above. Turn this to a markdown. And let me just write a note. So the more negative score, example, a -5, means a worse model performance or larger errors, and then a less negative score. Example -2. It means a better performance model or smaller errors. Let me run that. So now let's look at our cross-validated mean absolute error. And here we have a mistake. I spelled absolute wrong. Let's run that. So here we have our values. We divided our data into 5 subsets, and then we found the score for each of them. And we're gonna get negative values for each because sklearn converts the mean absolute error and also the mean squared error into a negative value. So now let's get the mean of these values. So np dot mean, and then we want the mean of our mean absolute values or mean absolute error. Let's run that. And here we got it, -0.46. If we want, we could just call it 0.46. We could take out the negative and just call it 0.46. So now let me do the cross-validated mean squared error. And I'm just going to copy this, Control-C, Control-V to paste. I'm going to call this CV_MSE. And I'm going to change this to mean squared error. So just change this absolute to squared. And now let's run that. So here we got our values. After we set a cross falls of 5, we divided our data into 5 subsets. And this is the mean squared error we got for each of the subsets. So now let's find the mean. Let's run that. And you see we got our cross-validated score for our model.